Hey guys, I was kind of hoping to start this class early. No, in the email I said 10 to 2. Yeah, I think I did, didn't I?
Yeah, 10 minutes earlier.
Huh? What do you mean?
No, you send an email.
Oh, we kind of like mixed it up with the regular schedule and we just thought that, sorry.
That's okay. That's okay. What was our last lesson?
The point chart thing.
What was it?
It was this electric field strength.
Yeah, are we on? I think we're on number 3, electric field potential.
Yes.
We have done strength.
We finished the second lesson.
Yeah, so we're on number 3. Okay. So, weren't you missing class yesterday, Adnan, at 9 o'clock?
No.
Interesting how it affects you at 9 o'clock. And you're recovered now?
No, I sent an email like the day before yesterday.
Was I copied in on it?
No, so
Oh,
and
what would it kill you to CC me in it? That extra line.
Because, I don't know, I skipped like more than one class and I sent it to all the teachers. Just like
I worry about you. CC me in, okay?
I first corner with the cover himself up.
What else? Right, electric field potential. What? Electric field potentials. Did you write that down? You got that? Can I continue? Yeah. Okay. So you know, when a particle is above the ground, it has potential energy. Because a force is acting on it, which would cause an acceleration, which would increase the speed and therefore kinetic energy. So the kinetic energy must have came from somewhere. It came from the potential energy at the start. When a charged particle is between two plates, it will start moving. Why?
Because of the
what, yeah?
the strength,
Electric field strength, yeah. So likewise, it's a force. There's a force, just like gravity, that's pulling it to the plate. It pulls the electron to the positive plate, and it pulls the proton to the negative plate. So it also has a potential energy. So by comparing this problem, by thinking about it this way, in other words, we can arrive at a formula. Let's have a look.
Maybe the energy came from it didn't have energy, but the energy came from the field itself.
Yeah, yes. Essentially, it's because of the field is the reason why. But we need to get a formula. So, in the mechanics picture, you have the ground. Come on. And this here has mass m, and it's at a height h. And there's a force acting here that's given it the potential energy, and the force here is mg, and the potential energy is mgh. All familiar, right? Now, let's look at the new situation. We have a plate, and we have a plate, and we'll have a positive charge here, and the positive charge moves in the direction of the field. So let's say the field is pointing down. So this particle will want to move down. And this one is a positive and this one's a negative. So you know that F equals QE from what we did recently. So if you compare the two, you have a force, obviously, and the force is equal to something about the particle, in this case its mass, multiplied by a constant. The force here is equal to something about the particle, in this case its charge, multiplied by a constant, in this case the electric field strength. So it's almost like these are the same problem, except instead of mass being the multiplication, it's a charge of the particle, and instead of the constant being gravity, the constant is being electric field. So if you were to make a guess by comparing it to something you've done before, what do you think the potential energy would it be in this situation when it's at a height h? No, because there's no n in this picture.
Q.
Q E H. Now, actually, I think for this one in the formulas they usually use the letter D, so we'll say Q E D. So we'll call this, instead of H, just D. So it's not quite a proof. It's I don't know if you know this word, analogy, like a comparison. So by comparing it to a situation we're familiar with, we can arrive at this formula. I don't know if there's any other words. Analogy, comparison, comparison. Okay. Got that?
Yeah.
Okay, so the formula is the potential energy due to an electric field is given by PE equals QEH. I apologize, I keep switching between small q and big Q, and I say this every year in every video. I haven't decided which one I want to use all the time. So Q, I don't know which is best to use, small or big. Anyways, it's charge. And I wrote H. I think in the formula book it's D. Yeah. What's what? This thing I've been talking about for 5 minutes. What is it? What's what? Yeah, but I'm not there yet. I pressed right too soon, just to hear. I will explain it now. Okay. Can I go back? You have this formula? Yeah. Now, what is the formula for E? Yep, that's right. And when it's parallel plates, you have another one. V over D. What cancels here?
D.
So you get another form. The potential energy is equal to the charge multiplied by the voltage causing the field. Often more commonly used. Got that? So it's just to what? Yeah. So it's common to see P equals QV because E equals V over D. This gives us something to think about for what the G is in MGH. So what's the E in QED? Electric field strength. So by making another comparison, what's the G like in MGH?
The force.
No.
The force.
Because the mass is the mass and the charge is the charge. But what's the G like? Well, what did we say the E was? Electric field strength.
Yeah, so like the
Gravitational pull,
yeah.
pulling
I like it. Adjust your words slightly. You have it started well. Gravitational.
force.
No. What was the E called? Electric field strength. So,
Gravitational field strength.
yeah. So if the G is bigger, then what can we say about the gravity?
Stronger.
And does that make sense? Yeah.
Yeah.
Yeah. And if the G is smaller, what do we say about the gravity? It's weaker. Yeah. So what I'm trying to get you to see, something we'll talk about later in the chapter, is another way we can think about gravity is that gravity is like a field, just like an electric field, that spreads through space, pulling things along with it. Do you get what I'm saying? No. I don't expect you to necessarily, because it's a difficult concept which we have to talk about later. But we have electric field strength. It kind of pulls through space, moving charges along. Yeah. Gravity is similar. Gravitational field is like a field that moves through space, pulling masses along. Particles with a mass.
I have a weird question.
Yes.
If like in the first like when we added the H,
Yeah.
MGH and M was there, so like the mass of the air itself, like one of the components of the air have like the biggest mass. Wouldn't that kind of particle be just like nearer to us? Hold more, and there's like only this type of it?
What type of particle? What's
Like oxygen, for example.
Yeah.
Let's say oxygen.
Yeah, oxygen,
There's
yeah.
this mass in there. Wouldn't like it mean there is only oxygen, then there is something else or something else?
because of different masses? Oh, you're saying it'd be oxygen first and then something else above it?
Yeah. Like if the oxygen has the biggest mass.
Oh yeah, for example.
Yeah.
Yeah, the atmosphere is stacked by layers, so the heavier stuff, or rather the more dense stuff, should be sinking to the bottom.
Yeah.
So oxygen would sit around the surface, whereas something like helium, which is, I guess, not as dense as it's not as dense as oxygen. It floats up. Then it sits on top of the oxygen. Is that what you're asking?
Yes.
Yeah. Well, that's true, but I'm not sure what your question is.
Like there is only one type of gas right now, like around?
Oh no, it'd be a mixture of oxygen and nitrogen.
Yeah, but like which one is lesser? Like do you see my point?
No, lesser what though?
Mass. Like it should be above because it has lesser mass than the other.
No, it should be in order. The 10 kilometers
Of mass
would
is
be all oxygen.
just like water and oil when you mix them.
Oh, yeah. Phew, I don't know. I guess it's not so much the mass, but it's more the density of the gas. So the mass is a factor, but it's also the mass divided by the volume. So I guess nitrogen and oxygen have the same density. So it'd be like mixing two orange juice and apple juice, you know, not like mixing oil and water. So yeah, I don't know actually. I think the nitrogen must have the same density as oxygen, and that's why they mix together at the ground level. Okay, continue. Okay. So remember, let's see if we remember. If potential energy is positive, we talked about this in mechanics semester 1, and I also told you at the time that most people have forgotten this by the time we get to semester 2. Has it happened to this class as well? Potential energy is positive means what?
Inelastic.
It's up, yeah. Inelastic, oh no. No, way off. We say the particle has potential energy, as you said. What about if it's equal to 0?
Kinetic energy.
No. No.
It's at ground level.
Yeah, but there's a particular word I wanted you to use for this.
Trap. No, trap is mine.
Mm.
Trap is mine.
Dun, dun, dun. It's free. And then if it's negative, it's trapped. You can write that again, but you have that in your mechanics notes. Possibly even with a note beside it saying you will forget this. So we have three situations for potential energy. Positive, it has energy. Negative, it's trapped and requires energy to be freed, which is when potential energy is zero. Okay, continue. Okay. Now? So you know conservation of energy implies that the initial energy of the charged particle must equal the final energy it has. So, for example, you don't have to write this down because again, this is a copy of the mechanics slide. The energy at the start equals the energy at the end, which means the kinetic plus potential at the start equals the kinetic plus the potential at the end. Since we have PE equals QV and Q is so small, we often use a different unit to measure energy. But actually, just before I go on with that, just to make the last point a bit clearer, here's two plates. Here's a positive, and here's a positive charge. What will happen to this one? It'll go down. Sorry, this is a negative, I meant to say. This one will fire down. At the beginning, what energy does it have? Only potential, which equals
QV.
yeah, or QV. And here, what type of energy does it have? It only has kinetic. The field is no longer pulling on it because it's hit the plate. I mean, it's reached the end. So that's a half mv squared. So we can say QV equals a half mv squared in this situation. Again, I'm just making the point that what you learned in mechanics about the energy is true and useful here. Oh yeah, we have to be careful. That V is voltage and that V is velocity. Yeah, so be careful with that one. Okay. Q is usually so small, the energy is also really, really small. And it's more common to use a different unit than the joule, because the joule is too big here. A joule is quite big when you're only dealing with electrons, so we need a different unit here. So we need this new unit called an electron volt, or an EV. And basically it's a tiny, tiny bit of energy. The definition is it's the energy gained when one electron is accelerated by an electric field under a potential difference of 1 volt. Now before you finish writing that definition down, I'll just show you that with a picture. Here is an electric field. Let's imagine that it has 1 volt here. And I stick an electron in this field. It will suddenly gain potential energy. How much potential energy will it gain? QV. Do we know the Q? Yeah, it's the charge of an electron, which is E. Do we know the voltage? Yeah, it's 1. So it's just E times 1, which is whatever E is. That's how many joules of energy it gets. So E is a very small number. So we call this much energy 1 electron volt of energy. Is equal to, what was the E? 1 point, oh, it's on the calculator, shift 23, is it? 6.02? Yeah, see. So 1 electron volt of energy is only this much energy. It's a small unit. I think I probably write the number here. Oh no, I don't. Okay. Yeah, you'll need to note that then if you want to think about it as a formula.
Do you
need to write the definition down? Of course you do, yeah?
Yeah, it's 1.602.
Oh, not 6.02.
Yeah.
1.602. times 10 to the minus 19?
Yeah.
Okay, do you want to write the definition down first and then go to the number? Mm-hmm. Got that? And have you got the number value? Yeah? So we've already done this. What's 1 electron volt in joules? This many joules. So there's nothing to do there. But what I want you to do for me now is convert the other way. 1 joule of energy is how many electron volts? Yeah. So 1 joule is many electron volts. We'll just wait for everyone to get it. Yeah.
6.242 by 10 to the power 18.
Okay, continue. Yeah. Okay. Yeah, I have a couple of examples here to do. So the first one, I'll do this one, but you can draw or write the picture, and then I'll do it now as an example to get started. Okay, are you ready for me to do it? Did you draw it? Yeah? Okay, so, what's the distance between the plates? 0.02, yeah. And there's a little electron here, and the distance is 0.02 meters, and the voltage? 500 volts. And my question is, how fast will the electron hit the plate at? So the potential energy here will equal the kinetic energy here. We'll ignore gravity because the mass of the electron is so small, the gravity force will be so small it will not affect the answer. So we have QV equals a half mv squared. So that means v, velocity, will equal 2qv over m square root. So, let's just hit that in. Charge of electron is it constant 23? Yeah. Okay, and the voltage is 500, and the mass is, what number is the mass? ME, is it constant 3? Yeah. Mass of an electron. Right, so the velocity is probably going to be a big number. Yeah, pretty big. Let's put that into kilo is 6. Yeah, let's put it in kilometers per hour, per second. 13,262.
Kilometers per second.
Yeah. Fast, huh?
That is like disappearing.
Crashes through the plate.
What's that?
There was no use of this time.
No, no, actually, no use of the distance. Unless I asked you for something like the time it takes to hit the plate. Did I ask that?
No.
How fast will it hit the plate? Okay, but if I did ask you the time, you would need the distance then. Is this okay?
Yes.
I can continue? Yeah. An electron enters a field which is at a potential difference of 10 kilovolts. The electron accelerates across the field until it hits a proton at rest on the positive plate. The electron binds to the proton and they move off together. The plates are 4 centimeters apart. How fast do they move? No, it's not. So, you have an electric field, which I'll just draw it here. And the electron enters the field, and because it's negative charge, it moves against the field. So the electron moves this way. And it hits a proton, which is at rest at the end of the field. So, what else do I tell you? It's 10 kilovolts. And the distance is 0.04 meters. So the first thing I want to know is how fast will the electron hit the plate? So we have the same deal. PE equals KE. QV, do we know Q? Yeah, electron. V, 10,000, equals a half mv squared. V equals, you realise this is the same as what I did a moment ago, except I think the only number that's different is anything different?
The voltage.
No.
The voltage is different, it's 10,000 volts. No, I just wanted to know for, if I retype it, what do I need to change? It's just the only difference is this is 10,000, that's it, 10,000 volts. So the velocity is this much, how many, what's that, 5.9, let's do 10 power 6. 5.93 times 10.7. Now that's not what I was asking for, because there's a second half here. The electron binds to the proton and they move off together. So the electron binds to the proton. So now you have a proton-electron pair, and they move off together. Do you understand?
Yes.
I want to know how fast do they move away at.
The mass of the distance.
The speed will be different as well.
Yeah, because of, but like
Yeah.
in the equation, so it's going to be the mass of the distance.
No, no. What equation do I need here?
deviating.
No, don't need that one. Yeah. The electron is colliding with the proton and they move off together. So the momentum before the collision equals momentum after the collision, yeah. So, the momentum before the collision is the mass of the electron times the velocity of the electron. And the momentum after the collision is the mass of the pair times x, which is what we want. So x will equal mass of electron times velocity of the electron, which we know, all over, what's the mass of the pair? That's the mass of the electron plus the mass of the proton. So if I hit that in on the calculator, mass of the electron is constant number 3.
3 and 1.
Great, and then the one down here is 3 and 1. And that must multiply by my previous answer.
190 by 10 to the power 7.
So the pair moves off together at a... Oh, what was my mistake in my typing? Yeah. They move off at, if I divide by 1,000, 32 kilometers per second. 32.3 kilometers per second. I like this one because mechanics. Yeah, you got that written down? Yep. Okay. Not yet. Okay. The only reason this room is free and this classroom is free now is because the students who were supposed to be here, all of them are in Cork today. So, I thought you might appreciate getting to go home sooner because I care. Right?
Should cancel both of you before you should cancel only one home.
Oh, you have.
Friday.
Oh, you have to go home at 3 o'clock. Oh, life is so hard. Oh, oh.
I have to.
What do you have to
I
do?
don't have to come to this. Like if you cancel the class.
Do you only come in for this class?
We have EAB in the morning and we don't have something new. We only work on the time. So I can do it.
The only thing you would be coming here for is attendance.
I should feel honoured that you're here, isn't it?
Last week,
No.
all of us, actually.
Yeah. Why are you doing an EAP?
We're doing the evaluation and summary for the essay.
English class. So
The chemistry essay.
Yeah.
Was that hard?
I don't know.
You won't know till you get your grade, I suppose.
I won't know till I start reading.
Well, that too. Alright, do you have this? Yeah. Okay. So next now. So, Musharif pointed out that when I talk about exam questions, I always say that this is a good exam question. So I need to practice saying when they're bad exam questions. What I would consider the most difficult topic on the exam is fields. But at least so far, I hope you can see if this is the most difficult topic, then, you know, that's not so bad.
Are we there for the hardest part yet? No.
I tell you which lesson. it's not, there's not really it's not really one hard lesson in fields. I think what students find hard is there's a lot to remember in fields that is different to the other chapters. Like these rules with left and right hands and things like this. Yeah. Yeah. Alright, so
But are these like A sections?
A or B. Well, the ones I'm doing, I guess they're more like A, but they could be part of a B. Like, for example, this one here, it might be more just one step in some larger fields question. Yeah? I know what.
I told him I will do it again if
You don't think you will do these in the exam?
I won't study it again.
But that leaves you with no choices. You said you won't do mechanics.
No, I won't do the field.
You'll do everything else but you.
That won't work for section A though.
I won't do it.
Oh, you're thinking. What is it?
It could be 2 section A questions.
10 marks.
10 marks. 10 marks is 10%. 10% is 1 grade. 1 grade could mean going to your first choice or going to your second choice.
Oh,
Or third choice.
All of this depends on the theory.
No, I'm just saying it's a bad strategy to decide not to do something when you have to do it.
okay, like study, but not like.
Yeah, don't.
your whole
Yeah,
time of the-
Yeah,
yeah. Just be able to do the section A questions in the revision. Because usually the section A questions are things like this. Okay, can I continue now? Yeah. So there's 10 minutes left. I'd like you to get a start on the homework then, and we'll do this next week. So
we won't finish it, and we won't do number 5 and 6. Can we do it at home?
Let's do 1 and 2.
It's not the first
Let's do 1 and 2.
Always 1 and 2 we will like. We will be dreadful and so.
yeah,
Why?
it goes easy, medium, hard.
I know, I recommend to do it at home, all the 6
All the 6.
in home, yeah.
But you could do 1 and 2 like in 2 minutes, and then you don't have to do it at home. Not everybody likes doing homework, Musharif.
It's homework, so how can?
Here's me trying to be a nice guy, letting you do some now. This is the thanks I get.
No.
Yeah, I'm not expecting you to get all 6 finished now. In fact, that would be the best present I ever got if you could do all 6 of them right now in 10 minutes. I'm just expecting you to get a start on them and then to finish them at home. Because I care.
Nanojoules.
Nanojoules, yeah.
The first one is 250 times E.
That's a 2.5.
Yeah, 2.5. Yeah, I know. Okay.
2.5 times E, essentially, yeah.
And the second one is, oh my god.
Nano, what is nano?
Wait, nano is
Minus 9.
okay, so 1.5 minus 9 over E.
Yes.
Yep.
Huh?
1.5 times 10 to the minus
You see, if he did that at home, he couldn't confirm that with me. Yeah, but I'm just making it a little bit higher because I have another class after you in this room.
Why don't you just like move the folder profile
No, I want to connect to my laptop so I can record it. And I did have a converter that I got off of Amazon that did work to connect the VGA to the HDMI because that's a VGA connection. VGA is the old one.
Yeah.
This is a high-def HDMI.
HDMI.
So I had to buy a little
To
converter,
convert
the VGA to HDMI, and it actually worked perfect for the first day, and then it broke on the second day. I don't know if it was too cheap or something like that. So I need to buy a new one if I want to use that, which I do because it's easier than using this.
Yeah. Så där i VGJ liksom.
Third also done.
Can we actually like do this?
You want me to see how?
Difficult it is.
It's not difficult.
Number six?
Number 6 or?
No, 6.
6.
No, I expect you to be able to do 6 because it's not a crazy Stephen question. It is it is something that you could get in the exam. In fact, I think I wrote this one in here because I saw it as a section B question once, something like it.
Is section B hard because like the idea is really hard, or is it because like they ask you for so much
Section B is a bit weird because some of the questions, it's random. It'll be random topics and random difficulty. So like for example, maybe one year you get a really hard mechanics question, like so hard it's just not worth doing. And then another year you might get a really easy mechanics question. And then one year you might get a really easy electricity one, and then another year you might get no electricity one. You know, it's a bit random. The questions are usually difficult because it's very hard to understand and draw the diagram to solve the problem. In other words, it's very hard to know what to use for the problem. So I guess kind of like what you're saying, the idea, of the question. Yeah?
I want to ask about like in mechanics, the
Yeah.
type is common in the B question.
Which one?
The type
It's pretty common, yeah.
in B. So I want
And A.
and
Yeah.
want to be the common in the electricity for B.
What's common in electricity? I would say
Yeah, sure.
for 50% of the electricity section B questions are Kirchhoff's questions. And then the remaining 50%, they usually go for a graph, or what do you say?
RC circuit?
Yeah, something like an RC circuit, and then you have to make a graph for it.
I thought it would be capacity.
Or capacitors, yeah. But you see, basically, they either go for circuits, which could be Kirchhoff or capacitors, or they go for graph, which means RC circuit and time constant. So the electricity kind of falls into two possibilities: a circuit type question or a graph type question. It's kind of the two flavors. Mechanics either is an easy mechanics or a hard mechanics. What I would call the easy ones are the UVATS ones. You know, a car is driving at this speed. These are, okay. Some of them are, and the hard mechanics questions would be usually, sometimes they have a hard projectile, or sometimes it's a hard turning force problem because the diagram. Yeah.
Okay, what's the best way to like be able to just practice on one lecture, or just do around?
No, because even though it's random, it will still be like something in the previous paper. You know, so like the question on last year's paper, where it was to do with something falling down a hole and how long does it take to reach the bottom and all this different type of stuff. How fast is it going when it hits the ground? You know, all this type of stuff. That was very similar to one 3 years before that, where it was a ball dropped down a well. So 3 years ago, a ball was dropped down a well. Last year, a ball was dropped down a mining shaft. So what difference does that make? You know,
In waves.
waves, they really favour the double slit. But don't worry, when we start doing past exam papers, you will see this for yourself.
How many do you think they do? Like how many exams?
I don't know, it depends on you. Because if there's the worst way to do it, which is often what happens, is I just do questions in class. The best way, what I would hope in a perfect world is I would give you a paper and then I would do all the answers on the board the next day because nobody tried it at home. In an ideal world, I give you a paper, you try it, you can do half of it, you can't do half of it, I do the half you can't do, and this way we go twice as fast. But I know that's not going to happen, because I know when I start doing revision, I'll give you a paper and nobody will do anything. I'll say, what is the problem? Do you want me to do all of it? And I'm like, yeah, okay, do all of it. So I'm really good at the physics exams because I get to practice so much every year. So, you know, give me a physics paper and I'll get 100, no problem. I must have done each paper like 5 times. No problem, you know. The problem is I wish my students would practice more papers at home, because I think they'd be shocked to discover that if they practice lots of papers at home, then they can like ace the test, because there is repetition and similarities between the papers.
How much percent would you say? Like 20% similarity?
Well, if you don't, you know, if you discount things stupid like a ball was dropped down a well, a ball was dropped down a mine shaft, that's the same question, you know. So if you don't count that, I would say the similarity between past papers would be like, I don't know, 75%. So, you know, this is why it sometimes disappoints me when I see a paper and I'm like, yeah, these are all familiar, normal questions I've seen before, and then people don't all get A's. Yeah. So some students ask me, should I look at the notes? Yeah, but you should only be looking at the notes beside the exam papers. You should be looking at the exam papers and only be using the notes to help you do the exam papers. Yeah. In ESAP on Monday, I have a lesson for Dennis to do with you to help you prepare a paper to try. You know what I mean? A bit like what you did with the mechanics. I'm going to have a lesson for Dennis so that you can take an exam paper and prepare the electricity question and then do the electricity question in class or at home. So in other words, it's just, I just want to give you something in the SAP to help focus your mind on how to look at an exam paper and prepare it to do it at home for practice. I hope you'll find the lesson useful. You said you found the mechanics one useful, so I'm hoping you'll find this one useful. You can let me know after ESAP if it was useful or not. If it was useful, great, we'll do more of it. If it was not useful, then I'll do something else.
Do you have papers of electricity questions only, like A, B questions or only?
You know, I used to do that, but then I realised this is not the best way to revise, because students think, oh, I should do all of one type at one time and then move to the next type. And I know it feels like logically that's the best way, you do a type, but I really don't think it is. I think the best approach is to do a whole paper at once, because that's what you're practicing to do in the summer. And the other advantage is by doing a whole paper at once, you're keeping all the topics at the same time fresh in your mind. So I know it sounds nice, and I know lots of students like this, and a lot of teachers give this to their students, and I used to do this for maths and physics, but I'm starting to think now the better approach is not this. Yeah. But of course you're welcome to copy and paste and put all the and make your own. Like the exams are up there.
Yeah,
but I haven't used anything in a couple of years, so I don't have anything fresh. Yeah. Okay, yeah.
Question 5. UVATF
How long would it take a proton to travel from positive plate to negative plate at the distance of it?
in the end.
Yeah, ultimately you will have to use UVATS.
We will do the thing that we did